How do we know that something is moving? Kinematics describes motion by means of displacement, velocity, and acceleration, while dynamics studies the force in relation to motion. In this session, we will look at motion in one direction. Specifically, by the end of the lesson, you will be able to apply the following. How do you know that something is moving or in motion? Translation is the term used to describe the motion of objects in one dimension. Motion may be displacement, velocity, and acceleration. We talked about quantities in the past, and as we described, there are two types of it, and displacement is a vector. To determine if an object was set into motion, we have to compare its position or the location of the object based on a reference point. With distance, we only add points to determine the translation or covered path of objects. But with displacement, we refer to its translation based from its initial position to the final position. When we look at translation for both these concepts, for displacement, we have to look at the points as positive or negative values based on the x and y axis or the one-dimensional space and indicate the change in direction. While in the case for distance, however, regardless of symbols, we add all values. How can the principles of kinematics influence innovations in transportation? Motion can be quite confusing as an idea. When, for example, you find yourself standing on a bus, it would seem like when the driver hits the pedal, the people outside are the ones moving. But in fact, you know that it's you who is in motion. Motion can be defined based on the position with respect to a reference point. Speed and velocity has been used interchangeably, but we already know that both of these differ in their type as a quantity. Speed is a scalar quantity, in which it is the distance traveled by a body at a given time, while velocity is a vector quantity of the time rate of change in position. In cars and GPS dashboard, we usually see the instantaneous speed, which is the speed at a particular instant of time. But if the car is a bit more advanced, it will be able to show the current direction taken, which is called the instantaneous velocity. Putting the destination in the dashboard usually tells the average time of arrival, which is based on the average speed taken from data from other vehicles on the same path. What needs to change to gain acceleration? GPS, or Global Positioning System, is one of the most essential innovations we have today. With it, our phones can display speed, distance, ETA, and even shortcuts to which direction to take. There are times when speed is needed for us to reach our destination faster, and for that, we have to increase our speed. Increasing speed refers to acceleration, and acceleration is defined as the rate of change in velocity. Maybe we haven't noticed, but every time we take turns or there is change in direction, change in velocity or acceleration also occurs, or maybe deceleration if there is a decrease in speed. Why should faster vehicles and heavy cars maintain greater distances? In the real world, objects don't move in a straight line. Cars, for example, overtake other vehicles for them to arrive faster at their destination. However, maintaining distances is required as with dynamics. The faster an object moves, the higher is its momentum, especially when cars are loaded. A sudden stop might cause an accident if at least a 3-second distance between vehicles is not observed. How does acceleration affect a body? Other materials. It was later found out that inconsistencies were caused by friction, or in that case, air resistance. Objects on Earth also are attracted to the center of the planet. This is called the acceleration due to gravity, which is approximately 9.8 meters per second square. In our time where early space travel is being ventured upon, we have learned the effects of acceleration to man. Positive G is the drag we feel from our heads when we get suddenly elevated, and negative G feels like our internal organs get compressed in our abdomen as we suddenly fall. These changes in G or acceleration are some of the things we cannot avoid as we venture into the early conception of early space exploration as we try to reach the zero Gs of space. This was the concept of motion in a flash. In this session, you learned about the following. Thanks for watching, I appreciate your time, and I shall see you again on the next one.